Let's see, a sub n equals 5. And let's see, n equals 1. So that's a times 1 squared is a. B times 1 is plus b. And c is just good old c. And then we have our third equation, replacing n with 2 and a sub n with 10. 10 equals, let's see, n is 2, 2 squared is 4, so this is 4a, plus n is 2, so 2 times b is 2b, and good old plus c. Now, we have three equations, a blue, a red, and a black equation, all of which are forms of the general equation, which is in green. We have three variables, a, b, and c. Three equations, three letters. We should be able to solve. What do you think our first step in solution is going to be? Well, hopefully you recognize that in the blue equation, and anybody who's colorblind, this equation here, that c equals 2 because 0 plus 0 equals c, so c equals 2. So right away we know that c equals 2. That was easy. Now let's look at the red equation. 5 equals a plus b plus c, but c is 2. Let's subtract 2 from both sides, and let me write this the other way. A plus b equals 3. Again, subtracting 2 from 5. If c is 2, these two equations are equivalent. And let's take the third equation, the black equation, and go ahead and replace the c with 2. Subtract 2 from both sides. We get 4a plus 2b equals 8. We have two equations. We have two letters. We certainly know how to solve that. We can use systems of equations with elimination. We can try to graph these. We can try to use substitution, which wouldn't be bad because certainly b equals 3 minus a or a equals 3 minus b. We could use Kramer's rule. We could solve it in many, many, many different ways. Let's go ahead and use the elimination process to review way back in chapter 11 and 12. So let's look at the next visual. And the next visual should show us that c equals 2, and that a plus b equals 3, and 4a plus 2b equals 8. The equations we just wrote. And now, how are we going to solve this? We are going to try to eliminate, well, we have a b and a 2b. If we can multiply the top equation by 2, we could have 2 b's in both equations. If we multiply the top equation by negative 2, we'll have a negative 2b and a positive 2b. So let's do that. And in the next visual, we see we've taken the equation that originally was in black, and we've written it, 4a plus 2b equals 8. We've taken the other equation, a plus b equals 3, and multiplied each term by negative 2. Negative 2a minus 2b equals negative 6. And then we've added the two equations up, eliminating the b's. 2a equals 2. A must equal 1. And if a equals 1, what do we have? We have a, we have c, we need to solve for b. So the next visual shows us that the remaining equation, a plus b equals 3. But a is 1, so 1 plus b equals 3, and therefore b equals 2. And we have the solution, a equals 1, b equals 2, and c equals 2. Okay, in the next visual, we have that a, n, our y value kind of thing, a sub n equals n squared plus 2n plus 2. That is, we've gone back to the original equation, and we've plugged in 1 for a, 2 for b, and 2 for c. There is a quadratic equation that's equivalent to our recursive equation. It will yield the same ordered pairs. And it says check. Let's check 4 comma 26. Because 4 comma 26 is a point we didn't use. Let's use a point. We have all these extra points. Use a point we didn't use to solve for a, b, and c. We plug in 26 for a sub n. 4 squared, n squared is 16. 2 times 4 is 8, plus 2 equals 26. Since 26 equals 26, we're okay. But just to demonstrate what we're doing, the board here, I'm going to go ahead and check the other point. So let's go back over here and erase all this stuff and take a look at our equation. And our equation, of course, is a sub n equals n squared plus 2n plus 2. That's our quadratic equation. It's equivalent to the recursive equation with which we started. We're going to check 537, which was the last point we figured out. 537, let's put that over here. There's your n, there's your a sub n. Okay, a sub n is 37. N squared, n is 5. 5 squared is 25. 2 times 5 is 10 plus 2, and indeed we have 37 equals 37. We've checked in 2 points, and that's pretty neat. So before we might only check one, here we check in things we haven't even used in the equation. That's kind of a nice thing about recursive equations. You can create more points if you want to check if you're unsure. And remember, if you go back on the tape to the visual that had those points, you can see now they weren't a straight line. They really were part of a parabola. Remember, we're not going to get the part where the n was negative because we don't allow, in the domain of a recursive function, negative values of n. Okay? Let's take a look at another recursive function. The next visual tells us that a sub 1, a little different here, a sub 1, there is no a sub 0, a sub 1 equals negative 5, and that our a sub n equals a sub n minus 1 minus 3n plus 2. And we've plotted for the points. I shouldn't say we've found for the points by finding n is 1, 2, 3, and 4. We know a sub 1 is negative 5, so we wrote in negative 5. And then it says to find a sub 2, take a sub 1, subtract 3 times n, that is 3 times 2, which is minus 6. So it's negative 5 minus 6 plus 2, which is negative 9. To find a sub 3, take a sub 2, negative 9. Subtract 3 times 3, negative 9 minus 9 is negative 18, and add 2, and you get negative 16. And doing the same process for an n of 4, we get negative 26. Okay, we have our 4 points. We look at the common difference as indicated. To go from negative 5 to negative 9, we subtract 4. Negative 9 to negative 16, we subtract 7. Negative 16 to negative 26, we subtract 10. Or, of course, because we added a negative 4, we added a negative 7 and added a negative 10. Let's take a look at the second difference since we don't have a common first difference. From negative 4 to negative 7, we add negative 3. From negative 7 to negative 10, we also add negative 3. If you weren't convinced that this is a common second difference, find a sub 5, a sub 6, as many points as you like. Find the differences and find the second differences. All the second differences will be negative 3. So let's look at the next visual. Here we have the second difference is negative 3. We have a quadratic function. Quadratic function of the form as shown in the highlighted second line, a sub n equals a n squared plus b n plus c. These are the first 3 ordered pairs. 1, negative 5, 2, negative 9, 3, negative 16. What I want you to do right now is stop the tape and find that quadratic equation. If necessary, rewind the tape, see how we did the previous problem, but solve for a, b, and c. And come back when you have them. Hopefully you're back now. That was pretty quick. It was even quicker for me. Okay, let's take a look at the next visual. In the next visual, we have the equations. Negative 5 equals a plus b plus c. Negative 9 equals 4a plus 2b plus c. And negative 16 equals 9a plus 3b plus c. We obtained these by replacing the n with first 1 and then 2 and then 3, and a sub n as negative 5, negative 9, and negative 16. Then we went on to solve the three equations. The first thing we did is obviously we found that we could not find C quite as easily as before, because before we had an n of 0. Here we actually have three equations with three variables. And how you want to do this, I will leave it up to you. If you're coming back to this tape to find out how to do it, I'm just going to give you the answers. That's good enough if all you want is the answers. But the next time you have a problem and the answers aren't the same as this, you'll have a little bit of a problem there, so you need to go back and check it out. The answers are in the next visual. A equals -3/2, B equals 1/2, and C equals -4. So those are the three solutions. Notice we also have a fraction involved. That's okay. And therefore, at the bottom of this visual, we see the equation. And the answer to this problem is, what is the quadratic equation equivalent to the recursive function? And here it is. A sub n equals -3/2 n squared plus 1/2 n minus 4. That is A, B, and C being replaced by the numbers we solved for. And in the next and last visual, we check. And we check using a point that was not used to find the solution to the three equations, three letters. We use 4, -26. And the second line, which is highlighted, shows us -26 equals 3/2 times 16, which is 4 squared, plus 1/2 times 4 minus 4. We've replaced the n with 4. And of course, we get -26 equals -24 plus 2 minus 4. And of course, -26 equals -26. We have checked. We are right. We have found the correct quadratic function using a system of three equations. So we've done quadratics and linear and systems in this particular lesson, and we learned about these things called recursive functions. In our next lesson, which is lesson 29, we will learn about sequences and series. That will not include the World Series, but it still might be interesting.